Now I want to redo our previous example using technology, specifically the TI-8384 technology. So recall that our example was about a study that was conducted in which 1,000 randomly selected Americans were asked if they believe the minimum wage should be raised. A total of 600 Americans in the sample said yes. Now, we won't go back and determine whether or not the requirements are met. We've already done that, and we did find that they were. So let's continue on then to find that 90% confidence interval estimate for the proportion of Americans who believe that the minimum wage should be raised. So what we need here is, for our technology, is we will need to enter the number of successes, which is our X, right? And we found there were 600. We will need to enter our sample size, N, which is 1,000. And so that the calculator can determine what the Z alpha over 2 is, our critical value, we have to tell it what confidence level we're using. So that'll be the third thing. So our confidence level will be 0.90. We enter it as a decimal. Okay, so let's see how we'll do this. Okay, so we'll go to Stat, Tests, and now we're looking for something with interval, with prop, proportion. We see interval, Z interval here. You may think that might be it, but we do need this prop in the name to distinguish it. So let's tab down till we see prop. Okay, I see two of them here. There's one prop Z interval, two prop Z interval. We just have one proportion, so we will use this one. One prop Z interval. Make a note that that's what you'll need. Okay, as I said, it's going to ask us for X. Our X is 600. Whoops. Whoop. Okay. Let's clear that. 600. Tab down to N. Our N was 1,000. And our confidence level is 0.90. And then we tab to Calculate, Enter. Notice it's giving us our confidence interval. It's done all the calculations for us, and it's giving us lower confidence limit, comma, upper in that interval notation. With the lower value here and the upper here, all we have to do is put it in the right format, round to 3 decimal places, and we're good to go. Notice it also calculated the p hat for us if we needed that, and restated our sample size. So we've got 0.57452 to 0.62548, so we'll round that to 0.575 and 0.625. So our interval is 0.575, 0.625, and if you go back and check, when we calculated this using the formula, we got the same thing. Okay, let's do this again with our 95% confidence interval. So, except for the confidence level, nothing has changed. Our X is 600. Our N is 1,000. And our confidence level this time is 0.95. Okay, we'll clear that and go back, Stat, Tests, one prop Z interval. Let's see, here we go. Enter. Our 600 or 1,000 still there. We'll come down to the confidence level and change that to 0.95. And calculate. This time we get 0.5696, so that would round to 0.570 and 0.630. Okay, so 0.570, 0.630. And again, if you'll go back and check, you'll see that is exactly what we got with the calculations. Okay. So that's how we use the technology to construct the confidence interval, it's important to know what the calculator's doing, and so we saw that previously, what's involved in these calculations that give us the lower confidence limit and the upper confidence limit. But now you can get it quickly using your TI 83 or 84. But there's one last thing I want to note, and that is that sometimes a problem will be stated in such a way that they give you p hat. So let's look at this. A study was conducted in which 870 randomly selected registered voters were asked if they voted in the last election. Results showed that 38% said they did not vote in the last election. Okay, so if we're to find a confidence interval estimate of the proportion of people who did not vote in the last election, success is someone who said, no, I didn't vote. That's what we're looking for here. Using TI 8384 technology, remember, we need an X. We don't have X. We're given N. N is 870. But they didn't tell us how many people. They just went ahead and gave us p hat. So we need X. Of course, we know our, well, we weren't given the confidence level yet. I didn't get that far, but I just want to show you this part of the problem. Say it's 90%, but we won't go that far with it. I just want to show you this. So what is X? Well, recall that if we needed to calculate p hat, we take the number of successes over the total number in the sample. So using this, we can see that, oh, well, if they give us p hat, then it's just to find X, we multiply p hat times n. You could solve this for X by multiplying both sides by n, right? Let's do that. So if I multiply this side by n and this side by n, of course the n's will cancel, and my result will be that X is equal to n times p hat. Okay, so let's find the X for this problem. X, because that's what the calculator needs, we have to enter X. Okay, N was 870, and p hat, as a decimal, 0.38. Or, in other words, think of this. It says 38% of 870 is the number that said they did not vote in the last election, which is what we're looking for. Well, when we do this, we get 330.6. Well, now, we can't enter 330.6 for X. X must be a whole number because you can't survey 0.6 of a person, right? X is a count. How many did you find? You can't count a partial piece. So we're going to have to round this to have an X. So we would round this as normal to 331 so that we could enter it in the calculator, okay? So our X would be that 331. That's what we would put in there. So you may, if the problem doesn't give you X, you may have to calculate X, and you may have to do some rounding. And just to make sure this makes sense, realize that, say they ran the study, and what happened was, you know, they end up reporting this p hat. How did they get it? Well, let's look at our numbers now. We're saying it should be about 331 out of 870, and if you do that, you get 0.3804. So it makes sense that 331 is a good number, the number actual counted. When they calculated p hat, they just rounded that to 38%, right? Just to make things easier. So that's why we got a partial result here, and we had to do some rounding, okay? So keep that in mind. If you're given p hat in the problem, you will have to calculate X to use your TI 8384 technology to solve the problem.